Hello and welcome to HomeWork6 Part 1. Here I'm going to show you a simulation of a ALU and a finite state machine. Here is my code for the ALU. Here I have a input of 2 bits and 2 4-bit inputs and 1 4-bit output. And basically whenever the select or the input, this input, is 0, 0, it's going to add whatever A and B was. It's going to add them together. And if it was a 0, 1, it's going to AND it together. If it was a 1, 0, it's going to OR it. And then if it was a 1, 1, it's going to NAND. And that's pretty much what the ALU is going to do. And here's the finite state machine. The finite state machine has a clock, a reset, and a 2-bit output. This output is going out from the finite state machine to the input of the ALU, and it's basically alternating from each state, starting from 0, 0 to 1, 1. And that's all what the finite state machine is doing. And here is my top level code. Here I've just added the components together. And here's my test bench. The test bench has signals, and the signals are attached to the respected inputs for the component. And I've just given random numbers to add to do the operations, the math operations on. And basically it starts off with reset 1 and everything else is 0. And I'll show you that in the simulation now. Just going to run the test bench. Okay. I'm going to add the components, the variables into the wave. And I'm just going to run it for 1,000 milliseconds. And here we have a waveform. So when reset is 1, outputs are zeros, doesn't do anything. And then on the first clock edge, when reset is 0, is going to do the 0, 0 operation, which is an add. So 0, 0, 0 added with 0, 0, 0 is in an output of 0, 0, 0. So that's correct. Then it holds for about 200 nanoseconds, and then at the next clock edge, it changes to an AND. So 0010 ANDed with 0010 is 0010. So that's correct. Now we're going to go to the next clock edge, which is right here. And this is going to actually NAND the two inputs. So 1111 NANDed with 1111 is 000. And then to the next clock edge, it goes back to OR, goes to OR. So 1111 OR with 1111 is 0000. And then at the next clock edge, it goes back to 00. So 111 added with 111 is all ones. And this basically concludes Hello and welcome to part 2 of homework 6. Here we are required to make a finite state machine that can control our ALU, but this time we are to account for the previous result that the ALU outputs from doing the instructions to A and B. So here I have the ALU. The ALU code is set up with one input, a 2-bit input. It's a selector which is going to select from the finite state machine if it's a 0 0 0 1 1 0 or a 1 1, and if it's a 0 0 it's going to add, if it's a 0 1 it's going to and if it's a 1 0 it's going to OR it, and lastly if it's a 1 1 it's going to exclusive OR it. And here is my finite state machine. That was the ALU setup. And for the finite state machine, I have it to see if the result is either a 0 0 or a 1 0 or a 1 1 or a 1 1 0 1. If it is, then it's going to go to the next states. If it's not, it's going to stay at the current state. And here's the test bench. This test bench is just doing it for a specific binary number, because if I do this number, it's going to go through every instruction. So I'll just show you how it's going to be simulated. So I run the test bench here, open the wave, implement the variables, and run it. And I'm going to make these binary so you can see it easier. Okay, so at the start it starts off with reset being 1, therefore nothing is happening here until the next clock edge, and reset is 0. So here we have a 0 1 1 0 and a 1 0 1 1. So it's going to AND these two together, which is making an output of 0 0 1 0, which is correct. And then it's going to go to the next clock edge, which is here, and it's going to AND or OR them. And if you OR them, 1 1 1 1 comes out, so that is also correct. And then it's going to exclusive OR, and output of 1 1 0 1 comes out, that is correct. And then after this, it's going to go back to state 0, which is just doing an addition, which is just 0 0 0 1, which is also correct. So this concludes my homework 6 part 2. Thank you.